Look closely at each list of numbers. Do you notice any difference among them? In the first example, the numbers are random and there is no pattern among the numbers in this list. In the second example, the numbers are arranged in ascending order, but there is no fixed pattern among them. For example, the difference between the first number and the second number is 1. The difference between the second and the third is 3. So, the difference between any two numbers in this list is not the same. In the third example, you can see a distinct pattern in the numbers. The numbers are arranged in the descending order, and each number is lesser than the previous number by 1. Let's learn more about such lists or sequences of numbers. Now, this list of numbers has numbers starting from 8 and descending to 1. Each number in this sequence is called a term. The first number, that is 8, is called first term. The second number is called second term, and so on. Thus, the nth number in the sequence is the nth term. And the last number in the sequence is the last term. When we subtract the first term from the second term, the difference is -1. When we subtract the second term from the third term, the difference is again -1. Similarly, the difference between the third and the fourth terms is -1 too. In fact, the difference between any two consecutive terms in this sequence is -1. Thus, we call -1 as the common difference. In other words, common difference is found by subtracting any term in a sequence from its immediate succeeding term. Common difference is denoted by the letter D. When a sequence of numbers has a common difference, we say the sequence is an arithmetic progression. Next, let's look at this calendar, which is also a sequence of numbers. The numbers start from 1 and go on up to 31. Here, 1 is the first term, 2 is the second term, and so on. Notice that the difference between any two consecutive terms of the sequence is constant. Thus, the common difference here is 1. So the terms in this sequence are an arithmetic progression with a common difference of 1. Now, you identify if the terms of this sequence form an arithmetic progression. Also, determine the common difference. In this example, the difference between any two consecutive terms, that is, common difference, is 2π. Therefore, we say that this sequence of numbers is an arithmetic progression with a common difference 2π. In each of these examples, we've seen the number of terms in the sequence is limited or finite. Such sequences are called finite arithmetic progressions. A finite arithmetic progression has a last term. Now, let's take the example of whole numbers. This sequence of whole numbers is an arithmetic progression because the difference between any two terms, that is common difference, is constant and is equal to 1. However, whole numbers are never-ending, and so the terms in this arithmetic progression can go on and on without end. This type of arithmetic progression is called infinite arithmetic progression. It is usually represented by 3 dots. Note that an infinite arithmetic progression has no last term. Which of the following sequences are an arithmetic progression? Also, classify each arithmetic progression whether it is finite or infinite arithmetic progression.